Welcome back to another Algebra 2 video. This is going to be the second video in our series on polynomials. Now in this one I'm going to show you how to find the roots of polynomials that are partially factored. Now, that's not really a technical term, but what I mean by that is something that is, well, been partially factored. Let's just jump in and I'll show you what I mean. If I were to give you something like this, that's going to be a quadratic, right? It's already been factored. You know this. And we would look at this and say, well, I know the roots of this. It's -2 and -5. That's easy. We've done this a long time. But what if we had more roots? What if we had something like this? Well, it's easy enough to see when it's in this form that if you just add another factor, it's just going to give you another root. So if it's fully factored, this is fully factored, which means all of these things are as factored as they can go. So the roots here would be -2, 7, and 1. Okay, very simple. And before I get into the partial factoring, let's give another example. Something like this. Again, it's going to have 3 roots. One of them is -7. One of them is 5. And remember, last time we talked about what happens when you have an x by itself. This is kind of like saying x minus 0 or x plus 0, either way. Point is, there's nothing there with the x, so the root's going to be 0. So I have 3 roots, 0, -7, and 5. Now, all these examples are fully factored, meaning they can't be factored any more than they already are. But sometimes you might be given something like this. Let's see. That's a good example. Actually, let me change this real quick. Let's do a different example. Let's put a 5 there. Okay. So notice this is technically factored because it's a polynomial comprised of things multiplied together. So I've got one factor here and another factor here. But while it's obvious what one of the roots is from this piece, 5, right? This piece, it's not immediately obvious. Now, how many roots are going to come from this piece? Well, remember our fundamental theorem of algebra says that the degree of our polynomial tells us how many roots it's going to have. So this 2 right here tells us I have 2 roots in this piece. Okay, we already know that it's a quadratic. So what are we going to do? We are going to factor it, and you probably already knew that. You probably recognize that already. I'm going to take that second chunk, that trinomial, using our new terminology, right? And we're going to factor it. What multiplies to give me 12 but adds to give me 7? Of course, that's going to be +3 and +4. Now, a lot of students like to skip this step. They'll go straight to the roots from this point. But I highly suggest you not do that because you have a very high probability of getting the signs wrong. So when I do this whole multiply and add and stuff and get the signs, that goes into these factors, right? That determines what the factors are, not what the roots are. To get the roots, what do? Well, I swap the signs. So now our roots are going to be 5, -3, and -4. Simple. So this is something that I call partially factored. While it is factored, it's not fully factored, and the roots aren't immediately visible, right? One of them was, but the other 2 were hidden. So let me give you another example. You guys do this one. Pause the video, right? You know how this works. Pause the video and give it a shot. Okay, I'm going to assume that you have tried this. So again, this is partially factored. It is factored, but it's not fully factored. Before we actually do this, how many roots does this have? Could you analyze that first? So the first chunk is going to give us 1 root because that's degree 1. This second chunk is degree 2, so it's going to give us 2. So it's going to give us a grand total of 3 roots, right? Just like the last example. So I'm going to rewrite this x plus 1. I'm going to break this down into 2 pieces. And what multiplies to give me 120, negative 120, but when I add it together, it gives me negative 2. Well, 12 times 10 is going to give me 120. It's negative, so I need one of them to be negative. Which one's going to be negative? Well, I need to get negative 2, so the larger number needs to be negative. So I'm going to have x minus 12 and x plus 10. So let's check it real quick in our heads. Negative 12 times 10 is negative 120. Negative 12 plus 10 is negative 2, and that works. So what are our roots? We have negative 1, 12, and negative 10. Okay? So that's how you deal with partially factored, where you have a binomial like the one on the left, and then you have a simple trinomial on the right that you can factor. Now, if you're ever given a trinomial like that and you can't factor it, you can always use the quadratic formula for it. And if you're not good at using the quadratic formula, factoring, you could always resort to that method. All right, let's try this. I'll give you another example, something you may not have seen before. But I want you to try it before you watch me do this. I really want you to see if you can figure out how to do it on your own. Okay. Now, before I show you how to do this, think about what this means. Really think about what that structure is, and try to write down the roots, and then come back and see if you did it right. Okay. Now, a lot of people will look at this and try to multiply this out or square things, and I want you to think about really what the definition of squaring is, and look at where that 2 is. Since this 2 is on this whole thing, what that means is it's that thing I've outlined in red twice, right? It's that times itself. So really what this is this. If I were to rewrite it, it's x minus 5 times x minus 2, but there's 2 of them, isn't there? All right. So it's not anything special or strange or anything I have to factor. I'm not factoring. What I just did, it looks like I factored because I turned one thing into 2 things. I did not factor. I just took something that was already 2 things and just wrote it that way. Okay? So now I have 3 roots. I have a 5, I have 2, and I have another 2. Now some of you might have some questions at this point, because I said I had 3 roots, and obviously there's 3 factors, so that means I have to have 3 roots, but it looks like I have 2 roots. I have 5, and then I have 2 twice. And I don't really have an intuitive way to explain to you why that is a thing. Not yet, at least. There is a good reason for it when we get into graphing, but I know you don't want me to factor or graph this yet. So we're not going to do that yet. But just know at this point that it is possible to have multiple roots being the same number. Okay? All right, and then I'll go ahead and tell you this. This is called multiplicity. So since I have 2 of these, this is called multiplicity 2. Multiplicity of 2. It's a bad example because the number is 2, but the multiplicity comes from the fact that there are 2 of them. Okay? Let's do another one. Let's do something like that. Okay. All right. This, you should be able to just see it quickly, so I'm not going to waste a lot of time with this. So the first term is going to give you a root of negative 3. The second term is going to give you a root of 5 and 5 again, because noticing that square is going to give you 2 pieces, right? All right, so I have negative 3 and 5 and 5. The other way you could write this, and this depends on who you ask and what textbook you look at and things like that, but the way I like to write it is I have a negative 3, and then I have a 5 with multiplicity 2. I just put a little m there that says there is a multiplicity of 2. Now, that's not any shorter than writing 2 5s, is it? But if I had a whole lot more 5s, you're going to find that that's going to be a lot faster. All right. Let's do another one. Why don't you try this one? I'm going to let you try this. Let's go, what do I want to put here? Let's go with that. That works. All right, you try this one, and then come back and we'll do it together. All right, now I'm assuming you've tried it. Now before we actually break this down, let's have a target. Let's think about how many factors we're going to have, or excuse me, how many roots we're going to have. So from this term, this trinomial, we're going to get 2. We know that, it's a quadratic. From this term, it's just the same thing. We're not going to factor it. It's just x plus 3 twice. So I'm going to have 2 of those. So that's a grand total of 4 so far. And then this term up here is going to give us 4 roots because it has a degree of 4. So that should give me how many? Let's see, 2, 4, 6. No, 2, 4, 8. 8 roots total. So let's write them down. I'm going to get 0 multiplicity 4. I could write 0 4 times, but this is where that whole shortcut's going to be better than writing 4 zeros. I have 2 negative 3s. So negative 3, negative 3. I'm going to write those twice. I'm not being very consistent, am I? And then, now this piece, I'm going to factor it kind of as a side note here. That's going to be, what is it, negative 3 plus 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. That's a negative 1x. So that works. So my 2 roots are going to be 3 and negative 2. All right, now see how many roots I have. I have 1, 2, 3, 4, and then 4 zeros for a grand total of 8, which checks out with our fundamental theorem of algebra. All right, let's try a few more, just to get some more practice, because I know you want to do more of these. Let's see. How about all right, try that one. Okay, I'm assuming you've tried it. So from the first term, we get a root of 0. From the second term, I get 2 twice, right? Multiplicity of, no, not 2 times 3. I wrote the wrong number down again. It's 2 with a multiplicity of 3, so I have 3 2's, right? Okay. And now the last term, we factor this real quick. Let me use a different color so it looks like it's actual scratch work over here like it is. What multiplies to give me 16 but adds to give me, or subtracts rather, because it's negative, to give me 6. That's going to be positive 8 and negative 2. 8 times negative 2 gives me negative 16. 8 minus 2 gives me 6. So now my roots from there are negative 8 and 2. Okay. Now let's go back and remind ourselves how to do some other factoring. I want to give some, this video is all about reminding you of all the different factoring techniques that we did a long time ago in that factoring video, and then applying them to this context. So what if I had something like this? Now, this is not to be confused with this. Side note. You see that? That means I have 2 x minus 9's. That's what that means. This is not the same thing. This is x squared minus 9. It is one factor. It's not 2 factors being shortened, right? This over here means 2 of these. This on the left is one factor of x squared minus 9. There's very, very different things. Okay, so let's talk about how we deal with that. This thing on the left, first of all, let's go ahead and get this out of the way. That's negative 2 root. But this piece on the right can be factored, can't it? You're going to ask yourself, what multiplies to give me negative 9, but when I add it together, cancels out to get rid of that middle term? Remember, usually you have this thing in the middle, and then like that number out here. Well, there's something supposed to be there, but it's not there, right? It's because it's canceled out. It's gone. So what multiplied to give me this last number, negative 9, but when you add it together, it goes away. Well, that means it adds together to give me 0. Well, that's going to be positive 3 and negative 3. So x plus 3 and x minus 3 are going to be my factors. So let's check that. 3 times negative 3, negative 9. 3 minus 3, 0. So that's why there's no term in the middle. Okay, and whenever you see something like that, you should recognize it. When you have x squared minus a perfect square, something you can square root, it's just going to be plus or minus that number. So let's actually practice that real quick. We did this in a video before, but it's worth noting again. If you have x squared minus 25, x squared minus 16, as we did, x squared minus 36, x squared minus 4, x squared minus 9, any one of these, if you see this pattern, that can't be plus, it has to be minus, you're going to be able to factor it the same way. I would actually pause the video and try these real quick, and then I'll go through them. But it's so imperative that you recognize this for the easy technique that it is, and don't give it much, mental thought, because I don't want you to get bogged down by this particular, technique. Brain power needs to be saved for other more, challenging concepts. Okay, so this is x plus 5 and minus 5. Oh, maybe I should slow down and write a little better. X plus 5 and x minus 5. This would be x plus 4, x minus 4, x plus 6, x minus 6, x plus 2, x minus 2. See how easy this is? So when you see something like this, I want you to have confidence, know that it's easy, and just factor it. Don't even think about it, just factor it. Don't look at this and say, I don't know what to do. Okay? Commit this to memory. All right, so back to our example. I'm going to have 3 roots. I'm going to have negative 2, negative 3, and positive 3. Okay? All right, another example. Here we go. Let's do this one. This should be fun. Let's do that. All right. Oh, that's not what I meant to do. Don't try it yet. Okay, do that one. All right, pause it and give it a shot, and then come back and we'll do it together. Okay, here we go. The first term, that's going to be 0, multiplicity 2, right? I have 2 zeros. You could write 2 zeros if you'd like. Now I have this term, which is going to give me 2 3s, or 3 multiplicity 2. All right, I have 2 of those. And this last term is not the same. This is why I did this way. See, the middle piece here, that means 2 of those. I have not factored. Please recognize I have not factored this. I have just written them both out because this 2 is shorthand for 2 of them. But this is different. This is not 2 of these here, is it? It has to be factored. It has to be factored into plus 2 and minus 2, right? So where this, the number didn't change because I didn't factor anything. But this, the number changed because I actually had to factor. There is a difference. I need you to see the difference. Both because you need to recognize it, and 2, think about what these things actually mean. And that'll inform you, or inform what you actually do. All right, so the roots are going to be negative 2 from the first one and positive 2 from the second one. So I have a grand total of how many roots? 6. All right. Now, what if I have something that's not factored at all, but is higher order, but then I can work? Now, a lot of times, if I have something that's degree 3 or higher, I'm not going to be able to just factor it. And that's what we're going to do in later videos. It's a lot more challenging. But there are some that you can do. Let me show you what I mean by that. Let me give you an example. I'll give a very simple example. Let's do, okay, that'll work. Now, most of the time, like I said, you're not going to be able to factor things with a degree higher than 2, okay? But this one's a special case, and let me show you why. If you'll notice, all of these terms have an x in them, right? So you have at least one x in all of them. So normally there's not an x in that last term, but right now there is. So they all have an x in them. So you can imagine that before that x was there was some x out front that was multiplied into this, right? So this came from someone distributing an x into this. So what we're going to do is undistribute it. That's a form of factoring. So we're going to factor out one of these x's. It doesn't go anywhere. It doesn't disappear. It still has to be written, so it's out front. And if I pull an x out of this first term, I get x squared. I've just removed one of them. If I pull 1x out of the second term, I get 5x. I pull an x out of the last term, I get 6. And now this looks like something I can handle, doesn't it? Now this is partially factored. Let's fully factor this. I'm going to leave my x out here, and I'm going to finish factoring. This is going to be x plus 2 and x plus 2 and x plus 3. Right? 2 times 3 is 6, and 2 plus 3 is 5. All right, and my roots are 0, -2, and -3. Not bad. All right, now, to clarify, most of the time, when you see an x cubed or higher, it's going to take some special techniques to factor, if it's not at least partially factored already. Okay? But in this case, if you have something you can pull out, go ahead and pull it out. All right? You try this one. This one's a little bit more challenging, but we'll see how you do. Let's see. Yeah, that'll work. All right, give this one a shot and then come back. Okay. First of all, let's ask ourselves, what is the degree of this polynomial? Well, we look at the highest order, or the highest power, and that's going to be 5. So that means the degree is 5, and that means that I'm going to have 5 roots total. Now, I'm also going to notice that there are some x's in all the terms, and since there's an x in all the terms, I'm going to be able to pull some x's out. Well, how many x's can I pull out? Well, if you look, they at least have 3 in each one of them. This last term is where you're going to look, because this last one is going to tell you, the smallest one, is going to tell you how many you can pull out, because they at least have that many, right? This one's x to the third, but there's at least 3 in that one, at least 3 in that one. There's, in fact, more. So we're going to pull out as many as we can. So let's pull an x to the third out. And what's left? X squared minus 2x minus 15. And now it's just a simple matter of completing the factoring. That's going to be x minus 5 and x plus 3. And that gives me roots of 0, multiplicity 3, right? Because there's 3 zeros from that first piece. And then I have a 5, and then I have a -3. Piece of cake. All right. A couple more examples, and then we're gonna be done with this. Let's do something like this one. I think that's going to work. Nope, that's not going to work. Give me a second. I have to do these in my head as I'm writing them down because I don't have notes for these things. I just kind of make them up, and I have to do them in my head forward while I write them down. Or excuse me, do them backwards. Let's see. I want to create that. Let's do that. Okay. Yeah, give that one a shot. This should work. Okay, you'll notice that just like the last ones, there's going to be an x in all the terms. So let's pull an x out. But if you only pull an x out, you're still going to see that you're still going to have this 2 out front. So if you remember back to when we did the factoring video, if there's a number out front and you can pull that number out of all of them, do it. So I'm actually going to pull out a 2 and an x, both. All right, so what's left? X squared minus 2x, right? And then plus 1. All right, and now I can factor this. and I get what multiplies to give me positive 1, but adds to give me negative 2. That can be a little tricky if you're not used to thinking about things with ones, because it gets a little weird. That's minus 1 and minus 1. Okay. Now, from this first term, this might be a little confusing because we don't usually see a number out front, a coefficient out front. But the 2 out front actually isn't going to do anything as far as roots are concerned. What that's going to do is change the graph and the flow of the graph a little bit. So we're not going to worry about that now. Later on, we can talk about that. But just for now, just know that it doesn't do anything. So that root is still going to be 0. These roots are going to be 1 and 1, or you could say 1 multiplicity 2. That's how that works. All right, let's do another one. Let's do negative. And okay, try that one. Okay, now, not only does this one have an x in every term, but it also has a negative in front. We call that like a leading coefficient, or leading coefficient of negative 1. It's this negative out front. And if you remember back a long time ago when we did our factoring, you can't leave that there and factor. Or well, you can, but it makes things difficult. So we just never did. So what you're going to do is pull that negative out of everything. You're going to undistribute that negative and that x. Let's pull both of them out. So I've got a negative x I pull out. Right, and the negative has to stay there. It doesn't affect the roots, but it will affect the graph when we start graphing these things later. I pull the x out and I get x squared. This is minus 8x and then minus 9. Now, if you tried to factor this by ignoring that negative out front and just trying to do the whole factoring with the multiplying and the adding, before, it wouldn't have worked, right? Because the signs were wrong. But now it will work, because now that's a negative 9. So what multiplies to give me negative 9, but adds to give me negative 8? Well, that's going to be negative 9 and positive 1, right? Negative 9 times 1 is negative 9. Negative 9 plus 1 is negative 8. All right. Now, again, this thing out here, the negative, is not going to affect the root, so it's just 0. And then I have 9, and I have negative 1. All right. That's how that works. Okay. Now, we probably should go through a couple the other way. Remember, in our last video, we talked about how we could go from roots to, a factored form of a polynomial, and then, of course, multiply it out to the standard form. Let's do that with this concept of multiplicity and see what that does for us. The easiest way to do one, it would be, well, let's say I have roots of 0 with multiplicity 3. And then I have roots negative 2 and 5. Well, we know about the negative 2 and 5. That's easy. So it's going to be x plus 2 factor and an x factor of x minus 5. This 0 multiplicity 3 had to have come from an x cubed. So I just leave it there. All right. Now, if you're asked again to write the factored form, this is the factored form of the polynomial, you're done. Most likely, though, you're going to be asked to put this in simplest terms or into standard form. So what are we going to do? We're going to multiply it all out. And what I suggest is leaving that cube out front alone and multiplying. Remember that trick we did? X cubed, this is negative 5 plus 2 is negative 3x, and then minus 10. And now we still have that x cubed out there. It's not fully in standard form, is it? So we're going to multiply through with that x cubed. So when you multiply exponents, you just add them together because you're counting how many you have, really, right? So I have x to the 5th minus 3x to the 4th minus 10x cubed. Not too bad, I hope. All right. Let me do one more. I'm going to do, now in my last video, I wanted to do one with 4 roots. I didn't get to it. I stopped with one with 3, or at least 4 roots that are non-zero. So let's actually do one of those because it is worth seeing how to do that. All right, I think this will be our last one of the day. Let's go with roots -1, -2, 3, and I don't know, 8. Sounds good to me. All right. So you know how this goes. If it has a root of -1, that means I have a factor of x plus 1. Root of -2 means x plus 2, x minus 3, x minus 8. All right. Now, with this, when you have 4 pieces, there's a bunch of different ways you can do this. You can even rearrange these if there's some that are easier to multiply than others, things like that. But we're just going to do it in the way I've written it here. You could multiply these two first, and then multiply through this, and then multiply through this. I assume that many students would see it this way, but let me show you an alternative method. What I like to do, it's not necessarily right or wrong. Well, it's definitely not wrong, but it's not necessarily the best way or not. I don't know. That's what I like to do. I'm going to multiply these two together to get a trinomial, and multiply these two to also get a trinomial, and then multiply those together. Let me show you what that looks like. And remember, with our trick of multiplying these things out, this is going to be actually very quick. And if you don't know what the trick is, you should probably get with it and see it from the... That sounded ugly. I didn't mean get with it. I mean, like, you know, give some thought to that trick and practice a little bit. Try not to be rude. Let's see, 3x, and that's 2. So now I've multiplied this left one to get this trinomial. Remember, we call it a trinomial because there's 3 pieces. And then I multiply the things on the right and get this trinomial of 3 pieces. And now I get to multiply all this out. Now it's going to look like a chore, and I get it. It's not going to be fun. Nobody wants to do it, but it is good for you. You got to get good at it. And I promise you, the more you do this, the faster you'll get at it, the more comfortable you'll be, and the better you'll be in the long run. All right, let's multiply this out. Here's how this works. I just take this first term times all 3 of these. So x squared times x squared, that's x to the 4th. X squared times -11x, that is -11x to the 3rd. And now I take x squared times 24, and that gives me 24x squared. Okay, so all I did, it's the same as I usually do, but I'm taking that first term and multiplying it now by all 3 pieces. All right, let's get rid of our guidelines here. Now, next one. X squared times, I skipped one. 3x times x squared. That gives me 3x to the 3rd. 3x times -11x is -33x squared. And now I have 3x times 24. And that's going to give me, what is that? 72x? Yes. All right. Now, we're going to go to that last term. I'm going to try and fit it all on the right side, but if you don't, you can always just go down, below. Actually, let me show you how that would work. So those of you who might be running out of room on your paper, you can do it this way. So it's the same problem. I'm just going to continue it below. So now 2 times x squared is 2x squared. And now it's minus 22x, right? And then it's going to be plus 48. All right. Now, before I start combining terms and all that stuff, let's take note of how many pieces there are. That was a lot of stuff, wasn't it? Well, there's 3 things in the first one and 3 things in the second one. It's a trinomial times a trinomial. And if you think about it, that kind of tells you how many terms you're going to have. It's 3 things doing 3 things each. That's 3 times 3. So how many pieces should I have? 9. And I actually color-coded it that way so you could see that. So this is 3 from the first, 3 from the second, 3 from the third. That's a total of 9 pieces. Now let's add them all up and hope I did this right. All right, so I have x to the fourth here. We'll cross these out, make our lives a little easier. Now, I should have 2x cubed terms. So I have a negative 11x cubed and a 3x cubed. That is negative 8x cubed. I'll cross those out. Now, if I did this right, I should have 3x squared terms. Now, this is 24 minus 33. That's going to give me a negative 7. Is that right? 24. No, that's a negative 9. Sorry, that's a negative 9x squared, and then plus 2, that's a negative 7. That's what it is. Okay. Okay, and now let me cross those out. Sorry, mental math. And now 72 minus 22 is going to give me what? 50x. And then plus 48. So again, it looks like a lot, and it kind of is. But like I said, the more you do it, the better you'll get at it. Okay. All right. I think that's going to do it for this video. Thanks for sticking with me to the end. And I think next time we're going to learn how to graph these things. So look forward to that. I'll see you all in the next one.